In the absence of universally effective strategies for the prevention and treatment of HIV/AIDS, significant research challenges remain for us to understand the complexities and vulnerabilities associated with the contraction of the HIV virus. Therefore, unconventional support has and will in the near future be commissioned as the world works to rid its populations of the virus.
Highly innovative and potentially high risk to help engage others from the outside that are not necessarily working on HIV to bring their ideas to the table to transform HIV vaccine discovery.
The burden of vaccine development was traditionally left to clinical sciences to grapple with. But the tentacled effects of the virus have been felt in the world's population far beyond the labs of the so-called soft sciences. The need, therefore, for collaboration from all arms of science is inevitable.
Essentially, enabling these technologies, what we've done is we've borrowed some ideas from the tools that are used to manufacture chips that go into your computer. So this is ideas from semiconductor industry to create little devices like this one.
These collaborative interventions are engaged to bridge gaps present in the search for vaccine, and as a result of such interventions, the imprinting technology was created. And its use
Diseases like HIV or cancers often reside in tissues, yet the clinical samples that we really have most access to easily are blood. We can look in blood, but that's not really where the disease is occurring in its primary site of infection.
The use of these technologies will ultimately be employed even beyond the creation of a vaccine for HIV.
We're thinking about the applications to things well beyond HIV. We're looking in cancer, autoimmunity, and even problems in manufacturing better drugs.
Core science interventions continue to be engaged through information scientists who support the sector to better trail the virus and its complex characteristics through data.
Taking ways of analyzing information in multi-dimensions and really understanding what are the fundamentally important things in the immune system that we need to understand in order to develop a vaccine.
So the way we did this was by using computational approaches that were developed in the context of high-energy physics and things called spin glasses, and had funny names like random matrix theory, which had also been used to analyze stock market price fluctuations. And so it was a convergence of ideas.
These collaborative interventions and the positive outcomes thereof have informed the donor community to awaken to the presented potential through these collaborations in search for a vaccine and a cure in the long run.
There are things that are happening that we're seeing happen. There are efforts underway, and we're trying to accelerate those to specifically target funding to young investigators, the minds that are going to carry this baton forward into the future.
For young science investigators such as Assistant Professor Christopher Love, accredited with the creation of the imprinting technology, this was a journey in new thinking.
You're used to solving problems where you have to build a new molecule or try out a new idea to make a material. And I think what was engaging for me about the problems in HIV research specifically was that here we had a problem that a lot of things have been tried, but there is no solution to it yet. We have ways to manage it, but we don't have a cure.
The engagement of core science collaboration is a move, though fairly new even in the developed world. It would be a significant adoption in the developing quarters of the world.
Is really a new way to think about doing science. And what's exciting about it is that not only are we able to ask new questions in new ways now, but we're starting to be able to bring in new perspectives like those from the engineering community.
Consilience and its importance is being recognized by a few people, and it's growing. But I'm not sure yet that it is the norm today. It's still something that remains a minority of things that are funded and supported and believed in.
Fundamentally, core science collaborations could hasten the efforts to create a vaccine in what has been a 25-year search and counting.
There's a need for a critical mass of researchers so that somebody can have the same kind of vibrant research environment in Africa that one can have in Europe or the US.
Beryl, Ooro for K24, Boston.